Hello, everyone, and welcome to today's webinar, How Ordnance Survey Uses Technology to Solve Real-World Problems. We're just waiting for some more participants to join, and we'll begin in a minute. We'll have a few seconds of silence, awkward silence, because the webinar is not a webinar without a bit of awkward silence. We've got an amazing panel lined up for you today, and I'm honestly so excited to get started, and I'm sure you are too. Feel free to grab a cup of coffee or tea. I've got mine here, and we'll start shortly. I can see the numbers going up, which is amazing. Okay, perfect. I think we'll get started. So for those who've just joined us, welcome to today's session. My name is Joanna Silva, and today I'm going to be the moderator of the How Ordnance Survey Uses Technology to Solve Real-World Problems webinar. Thank you for taking the time to join us. Before we kick things off, let me just give you a quick sneak peek of what we'll be covering in today's session. We'll start the webinar by exploring Ordnance Survey's technology landscape, including its modern, data-centric and cloud-first approach. Then we'll dive into the role of an architect, delivery manager at Ordnance Survey. We'll then explore what it's like to work on projects that deliver real-world benefits across Britain and internationally. And to top it off, we'll wrap things up with a look at information security, what is it, and roles at Ordnance Survey. Just a little housekeeping. If you have any questions throughout the presentation, please type them into the QA box in the Zoom control panel at the bottom. I'll be able to see them during the presentation, and we'll also have some time at the end for questions. So if there's any topic that you'd like our panelists to dive into, feel free to pop the questions in a Q&A box, and at the end we'll answer them. Now, I would like to introduce you to our speakers. Today we have with us Ian James, Mark Goodrich, Sofia Taglialavore, and Peter Smith. I will hand over to Ian, and yeah, you can take the floor. Thank you.
Thank you, Joanna. So yeah, just to introduce myself, Ian James, I'm the head of architecture at Ordnance Survey. So my role oversees a team of solution, data and infrastructure architects and a team of business analysts. And our job really is to help kind of shape and direct the technology solutions that we deliver at Ordnance Survey. So it's going to start off a little bit. We're giving a bit of a background to Ordnance Survey, who we are and what we do. Don't know if people really know what Ordnance Survey are, other than the people who produce those pink maps that you see in WH Smith's. But we are much more than that. So we're an organisation that's been around for a long time. We are we call ourselves a local location data authority for Great Britain, but essentially our role is to deliver a national mapping service to the country. That's our kind of remit, has been that remit for over 230 years. And so we've really been at the forefront of technology over that whole kind of period. And we underpin a lot of what the country does, particularly from a public sector point of view. So what we really kind of do, we are about providing value to our customers. We do that in a number of ways. One of that is about providing authoritative data. This is the data of the geography of Great Britain that we provide to our customers and their kind of partners to enable them to do their job. We also provide scalable solutions that build on top of that data and other data, be that the customer's data or other geographic data, to provide specific solutions to specific needs that our customers may have. And we also are a provider of geospatial expertise. So we provide knowledge in terms of allowing people to use geography, use our data, and to use that data to solve the problems that they may be facing. At the heart of everything that we do is the thing we call the National Geographic Database. And this is the most detailed map of the whole country that we maintain, that we keep current, and that we publish to our customers and services. So that's like a kind of quick kind of overview of who we are. So what I want to talk a little bit about is our technology landscape. We are an organisation who supports innovation activity, and we are, as I said earlier, at the kind of sort of forefront of the application of technology to kind of mapping the country. We have an organisation called geospatial, which is a sort of startup program that helps innovators to get their ideas off the ground and move those kind of things forward. So we've had a lot of success in terms of creating jobs and creating investment of that. We've got a number of services that we are starting to kind of build off the back of that. And there's a number of areas there that we are kind of engaged with, things like machine learning, 3D digital twins, AI, hyperspectral sensors. These are all areas where we take technology and apply that technology to the job of mapping Great Britain. There's a number of areas here that I'm not going to go into all of these, but just to give you a flavour of some of the areas that we touch on. So things like aerial imagery and Earth observation using satellite imagery, a kind of core way that we kind of collect data. We use drones as a source of doing that as well. We take lots of different types of data, so we build 3D meshes of data, use hyperspectral data where we can analyze the landscape. So a lot of kind of different ways that we capture and use data. But we also are very much a kind of cloud-first organization. We are using the cloud as a platform that enables us to deliver a lot of this technological innovation. So we have standardized on the use of Azure as our cloud platform, but we use technologies like Spark. DevOps is a big part of the way that we run and organize and develop our kind of applications. So a lot of different technologies that all come together and that we kind of use to help us do the job that is in front of us. This is a really high-level overview of how we kind of how we see our technology landscape as a set of kind of end-to-end capabilities. So we start at the kind of data capture end. That's very much about us kind of capturing information, whether that be through aerial and satellite imagery, whether that be through a team of surveyors that we have out on the ground that are actually surveying the landscape, or whether that be bringing in other data sources into the organization from other organizations. We have then started over the last kind of few years, there's a big kind of development in terms of our automated data extraction. So that's really about taking those data sources that we've captured and applying things like machine learning, computer vision, geospatial analytics to that data to derive value, to derive meaning from those data sources. Then we kind of have a process which is really about our data derivation, where we take all that information and at high volume, at scale, we kind of engineer and aggregate that data to produce a set of usable products that our customers can consume. And then we have a data access layer, which is really about providing API-based access to that data and giving customers direct access to our data. We also provide secure data hosting and services for other customers as well, who may have specific needs around their data or other data. And on the kind of far right there, we have our customer app. So we publish a mobile app, which allows our consumer customers, people who want to go out walking, out in the great outdoors, they can consume our data via a mobile app. And that is now a bigger use now for our data than the old paper maps that a lot of people may know. That is all underpinned by a set of business operations. From a technology point of view, we need to kind of run the business. So there's a whole bunch of applications and services that run the business. That's built on a set of common infrastructure. So common kind of sort of servers, networks, kind of storage infrastructure. Again, a lot of kind of cloud focus for that, although we do have a legacy of kind of on-prem kind of sort of infrastructure as well. And that again is all underpinned by kind of information security. We are a data organization, and the security of our data and the security of our services is really key in terms of giving customers confidence in who we are and what we do. I want to talk a little bit about our kind of technology principles, which gives you a bit of flavour, I guess, of the way that we kind of approach the use of technology. I'm not going to go into all of these, but we are very much an organisation that wants to take technology and apply technology to address kind of business problems that we have and business problems that our customer has. So as I said, we're very much a kind of cloud-first organization, and that's our kind of direction of travel. So everything we do new now tends to be kind of built on the cloud. But we are one who is not kind of using technology for technology's sake. We kind of try to avoid diversity in our technological landscape, trying to avoid unnecessary complexity. We kind of keep it simple. We kind of want to make sure that actually this is a sustainable technical landscape. So we have these principles that we apply to all of our kind of technology developments. The one top right is key one to kind of highlight. Then again, secure from the start. Peter will touch a bit more on our security approach a bit later. So I want to talk a little bit about the role of architects at OS, because that's my kind of focus. This is the rough shape of the team that we have. So we have a team of business analysts, team of data architects, solution architects, and infrastructure architects. Business analysts are really focused on understanding the business benefits, the operating model, the business change that we need to apply. So this isn't all about technology, it's about how technology enables us as a business to do the things that we need to do. Team of data architects then, who are very much focused on sort of data requirements and data models, data flows, data roadmaps, those kind of things. And being a data organization, that's a far bigger team than you would kind of maybe normally expecting in other business, because it's so much at the heart of what we do. We then have a team of solution architects, and their focus is really looking at the overall solutions that we're kind of building and operating. So looking at things like the conceptual and logical architectures, the component architectures, security, non-functional requirements, the roadmaps for our applications and services, and how those kind of move forwards. And then a team of infrastructure architects. And those infrastructure architects are very much focused on that common underpinning technology. So your service, your storage, your network infrastructure, and the common underpinning technical capabilities that are required for us to be able to run a business. So we kind of manage the team in that way. One thing that's important to say is that while we have these different disciplines, actually what's really important is that these people work together to provide overall solutions to the business. And so it's very much a kind of collaborative effort between the kind of various roles in the teams. Those architects don't work in isolation. They're very much a team of people who operate together. But they don't operate within isolation either. They operate as part of a broader organization. So very much the architect kind of team is about an enabling team, who's about joining up, who's about making sure that actually people like the engineers that the solution architects work with, the kind of business stakeholders, the end users that the business analysts work with, the kind of data analysts who the data architects kind of work with, and the guys and girls who are actually kind of involved in the management of the underpinning infrastructure. The infrastructure architects work with these. So it's very much a kind of collaborative, team-based environment. We're very much encouraging people to actually kind of work with people, and so very much we kind of focus in terms of these roles, in terms of people who aren't just technically good and technically very good, but actually are people who are good kind of people persons who can actually work with other people, who can engage, who can influence, who can operate with a broad section of people within the organization. So that's a kind of brief overview of how we kind of operate and run architecture at Ordnance Survey. And I'm going to hand over to Mark Goodrich now, who's going to talk about system development at OS.
Hi there. Yeah, so I'm Mark Goodrich. I'm the head of systems development and maintenance Ordnance Survey, and I'm joined actually by one of my colleagues, Sophia, who's recently joined as a senior delivery manager. And we're just going to kind of talk to you a little bit about how we engineer kind of technology-based solutions at Ordnance Survey. Next slide, Ian. So this is kind of similar to the view actually that Ian showed you earlier, and I really like Ordnance Survey. It's quite a linear kind of business, kind of like the GCSE IT principle of input, process, output, and to some extent that's kind of how you can talk about Ordnance Survey. So most of our effort goes around building systems that enable us to capture data from various different sources, then take that data and refine it, mill it, derive value from it, and then make that data available as data or information to our kind of customers. So most of our effort traditionally has been in that first stage. So Ordnance Survey used to be an organization that really just collected large amounts of data around the UK and then made that data available, you know, even doing such things as shipping data to customers on hard drives or DVDs. So really most of the technology and investment was in that data capture space. We've got a lot of experience building our own GIS applications or taking other people's GIS applications, customizing those, configuring them and building on top of those. However, more recently, you'd be perhaps pleased to know we don't really ship data to people on hard drives anymore. And actually, we're trying to move away from shipping data and it's much better to provide information services. So there's a much stronger focus now on how we engage with our customers and how we supply that data. So we've built up a lot of experience more recently in sort of digital fulfillment services, the ability to build various different APIs, and then also to make that data. We have a lot of expertise in that what's called here the data aggregation space, where we're taking data that's been captured and we're doing stuff with it. We're applying our expertise to derive extra value from it. Next slide, please, Ian. So how do we do this? So at Ordnance Survey, our technology function is about 400-ish people, about 420 people. That's internal. That's then supplemented by some external specialists. But yeah, in Ordnance Survey, we're kind of the full systems development lifecycle is operated at Ordnance Survey. Ian's team design applications in conjunction with our customers and colleagues, and in conjunction with the software development teams that Sophia and I look after. We then build those applications with consultation from the likes of Peter to make sure that non-functionally they're appropriate and optimized. And then we also then support those applications going forward. So we really do the full spectrum ourselves with relatively quite a minimal amount actually outsourced. Our expertise is traditionally in geospatial systems, digital fulfillment, and I think more recently mobile apps. And we've grown our machine learning and AI capability quite a lot in the last couple of years, but realistically that's been something we've been investing in for about 10 years now, and we've got quite a mature capability in that space. And we see this as being one of the fundamental kind of areas of the future of Ordnance Survey, as we perhaps move towards deriving data through lots of different kind of remotely sensed sources, rather than just relying on kind of Ordnance Survey traditionally using surveyors who would go out in the field and capture data. But I think you could say really our specialism is in data engineering. So whilst we are a software house and we build software applications, all of those applications are a means to an end. None of those applications we build are the products themselves. They're all there to enable us to create data or to process data and therefore kind of derive information from that. And next slide, please, Ian. So yeah, I mean, Ian said that we tried to keep it simple. I think it could always be more simple. I think for the number of people we have, actually, we operate a pretty broad spectrum of technology. But as Ian said, we do tend to focus on some of the more Microsoft-based services at the moment. We're very much heavily invested in Azure and use Azure DevOps to drive a lot of our development activity. But Java, Python, C#, there's a range of different kind of programming languages that are being utilized in Ordnance Survey, and some pretty exciting emerging technologies. I mean, Databricks has become sort of fundamental to how we develop and process a lot of our data as well. But we also have a really strong connection with some of the major GIS providers. So Esri is one of the ones we have a very close relationship with. We're often helping them innovate their new solutions, but as an early adopter of a lot of their products, provide them feedback and help and try and steer the direction of some of those things. So we work with a pretty broad spectrum of especially GIS and database providers. Yeah, Sophia, I mean, you've joined more recently. What's been your thoughts on that?
Yeah, so I've been at Ordnance Survey from the beginning of this year, and previously I've worked across a number of different software solutions. From coming into OS, I would say that the maturity of the way that OS uses those solutions is quite advanced. There's years and years of experience of knowing what works well, but also what needs to be improved and migrated in order to support the future solutions. So with a lot of the work that's happening at the moment around the cloud-based solutions and the security pieces, the engineering team aren't just thinking about what needs to be done by the end of this year. It's what do we need to structure in order to support the future of geospatial and location data in like 10 years time. So there's a lot of short-term and long-term thinking that gets connected with the different levels of technology solutions that we use.
Thanks. Next slide, please, Ian. So just kind of to think about sort of how we work, I would sort of describe as, I think the phrase I use is post-agile. So we are an old organization, and so historically we were pretty steeped in generally quite waterfall-based processes. About 10 years ago, I think like a lot of organizations, we finally embraced some of the more agile thinking and started to incorporate a lot more sort of progressive methodologies into our ways of working. Where we are now is I think that those are no longer kind of viewed as a bit of a panacea or a holy grail, and actually more just sort of par for the course. So I think the way we like to work now is we're considerate of lots of different methodologies and ways of delivering solutions. And what we like to think is, I guess we use a context-based approach. So we look at the context of the problem, the potentially the appetite for risk, the kind of thing we're doing, whether we're doing a data center migration might lend itself towards working more of a waterfall way, or if we're working with a product manager to perhaps innovate a microsite for a new product launch, that could be much more sort of a highly kind of iterative and incremental methodology. So we like to think of ourselves as perhaps, rather than someone who evangelizes any particular method, that we like to think we're kind of considerate of all the methods, and we choose what works best. In terms of that spectrum of kind of how progressive I'd say we are as a function as well, one of the other areas I'd say where we've moved forward is that we've moved away from the concept of having people who build applications and then people who support applications. The concept of transitioning things out of development teams into support teams was something we struggled with for a long time, and I think we've sort of given up on it, actually, in that the best people to look after something are the people who build something. So our concept of a team is we have a group of people who are grouped around a particular area of context. So that could be the data capture systems, which actually is conveniently where Sophia is currently based. So Sophia has a number of teams who both build our new data capture systems and support existing ones. Sophia, do you want to talk a little bit about how that works?
Yeah, so within the data capture area, so when we talk about data capture, we're talking about the different software solutions that allow our teams to capture real world change. So that's from software tools that allow our surveyors to go out in the field and actually measure how big a house is or how big the plot has changed, to also, as we've mentioned, some of that remote sensing data as well, which is our planes that fly over the country, and also drones and other data like that. So the software solutions that we have for that, we have a number of teams that work on building that with a number of different skill sets in different specialisms and areas. And we've set those up as cross-functional teams so that they deliver the new features, but they also are aware of the support requirements that might be needed. That way, that knowledge that was built on the decision that you made 6 or 12 months ago to address the requirement then is still held within those teams. There's a sharing of knowledge that always needs to happen with those cross-functional teams, whether you have people that move in or move out or work on something new, which is always something that has to get addressed and supported. But the value of those teams having that information means that you get a quicker solution that needs to be applied, rather than it going through 4 rounds of validation for it to finally get to the right person. So it's not about having multiple people trying to make sure that everyone understands the problem. It's about getting the problem to the person that understands it the fastest. And as Mark said, we've got different ways of delivering those solutions, but also fixing those problems that works in the right way for the right sets of teams. So Agile and Scrum might work better for some of the more established teams within the data capture space, but actually in the machine learning space, we might need to work more incrementally, because the software and the technologies that we're using in there are far more they're newer in terms of how we need to train the machine and what the output might be. It's far less predictable than data solutions that we've done before. So yeah, we're adaptive because we need to be, and because one size doesn't fit all within these spaces.
Perfect. And you talked about cross-functional kind of teams there. Actually, I don't know if you want to just talk through the next slide as well.
Yeah, so as we've mentioned, we have cross-functional teams. So what that means is there are multiple roles that we will work with in a cross-functional team in order to deliver the final solution. So we are not waterfall in as much as Ian's team will work on something and then it gets handed over to the delivery team, and that's the first time they'll see it. What we mean is all of those various roles, from the person that's leading the corporate strategy to the product owner that's defining the requirements to the principal engineer that understands the solution, all of these people listed in the roles are all in the right meetings at the right time. So we're working together to define the solution, define the requirements, shape and size it into releases that make sense, and then plan it so that it gets delivered as the right release, or the right UAT phase, or the right first iteration to be validated with our core users. We work together so that you have less handovers, so that we're all singing off the same song sheet. And the role of the delivery manager is essentially to work within all of those teams to make sure that we're applying the right methodology at the right time, with the right number of people, with the right skill sets. And when all of those things perhaps don't align, it's then part of the delivery management role to flag it and try and unblock and resolve it. When the delivery manager will work across a whole capability or department, and they will have multiple different projects within multiple different teams happening at the same time, and they are a linchpin to making sure the status of each of those is understood, and primarily that the blockers are resolved. So my day can go from talking about machine learning in the morning to field surveyors by lunchtime, to ending on the data upgrades that might be needed on an old system that massively underpins everything that we do but isn't actively being developed on. And it's part of the delivery management role to be across all of those things to help keep things moving. So an important cog within a very, very big machine that all has to process the data through to the end.
Thanks. And I think that's over to you now, Peter, I think.
Oh, thank you very much. My name is Peter Smith, the Chief Information Security Officer at OS. And I thought I'd just start with the very first slide. Doesn't show you a great deal. Well, it also does show you a great deal, but it gives the context of why anybody at any organization cares about information security. This is a point in time screen dump from a live website from Sonic Wall that shows all the attacks that are going on in the world currently. So this is it was taken as a screen dump probably a few weeks ago now, but you can see that there's different types of attacks going on continuously. They're coming from the US to us, from us to the US, from Russia to us, from China to us, from Japan to us, from North Korea, there's a nice big blob down there, to us and to the US. And it's an ongoing issue that everybody has. So just the next slide gives a bit of context about how things have evolved in the information security world. 10 years ago, no one really cared about it. Because if you look back at sort of, or 20 years ago, so the very first worm that came about was something that was exploited. People know about it, IS servers, so that's Windows web servers, and it just defaced them. So it was annoying. That was it. It just defaced your web server. You can deal with that one. You don't need an information security function to deal with that one. You need a web administrator to deal with it, and probably to switch off the account that did it. So that was relatively trivial. Then we move on. I've missed out quite a bit, but the next really big one that's probably worth talking about was TalkTalk. Probably people heard about that one. It was in the news an awful lot. Even the CEO had to resign afterwards. But actually, it was something really pretty trivial. There was an old database that was left lying around that had a very simple SQL inject vulnerability. So basically, you could chuck some code into the UI, and it then spewed out all of the contents of the database. But that was just executed by somebody in their bedroom. It wasn't a major crime really, and the data involved was actually relatively trivial. But so far, no money involved, no extortion. We move on a bit. We move on to 2017, and WannaCry reputedly came from North Korea. This is the beginnings of state involvement in cybercrime, and it was a lot. It was sort of accidentally spread, really, and the payments that people were being asked to get rid of the ransomware was $300. So in terms of scale of payment, relatively small, but it affected a lot of organizations globally, was a real inconvenience. And this is when the cyber industry around this time really started to get going and to be needed by all organizations. And then we're moving on to 2022. We've got the likes of Conti, which is a ransomware as a service offering, It's run by this particular one run by a Russian outfit based in Russia, but they obviously don't execute their ransomware in Russia, else they wouldn't have a very good business strategy going forwards. And it is run like a franchise. So if you think of it's equivalent of McDonald's or something like that. So you have the overall enterprise that's based in Russia, and you can be an affiliate. You have to pay $1 million to become an affiliate, and then you can use their ransomware tools. And it's big money. And this one group in particular, Conti, this is just one, they do change the name and evolve over time, has been behind two big ransomware incidents. There's probably heard about Royal Mail, and it took out all of the international parcel services. And they've even gone as far as taking out entire governments. So the one that's probably has most notoriety was an attack that removed all government systems in Costa Rica. They had to resort to basically doing things by paper. And they are Russian based, and the ransom demands are typically in the region of 10, 20, 30, 40, 50 million. So it's gone from something that's being really, really trivial to something that's big business internationally and state backed. So that's how it's evolved. The current threats that we face today are on the next slide. Again, it's just talking about it isn't something that's that script kiddies we're worried about. It's nation states attacking us and attacking everybody. And there are three main actors in this space. One is North Korea, and their raison d'etre, what they do in life is rob banks and crypto exchange heists. And they will typically make $1 billion a year out of that. And that's their only source of foreign exchanges through cybercrime. And it's big business for them. They have effectively bits of the government that focus on doing this. We're not particularly concerned about North Korea from Ordnance Survey's point of view, because we're not a bank and not a crypto exchange. But there might be a time when they move on. But basically, their current mode of operation is to steal money. The next two where we are concerned is Russia. As I mentioned, that they basically have an awful lot of ransomware gangs that are resident in their territory, and they do attack organizations that are based in the West. That'd be US, UK, Europe, Australia, etc. And they have immunity from prosecution in the country they operate in Russia. And if you look at some of the source code of some of their ransomware tools, they've even got code in it which looks for geographically where they're based, where the code is executing. And if it's based in the former Soviet Union, it doesn't execute. And that's quite common. We see that in the code in most of the ransomware we see these days. So, but they make quite a lot of money out of it. Typically, we're looking around 400 million they make out of it a year, collectively as Russia. And China, it has a different mode of operation. Their concern is about stealing intellectual property, not money, and to support their industrial strategy. So they've got things like that. One of the key things in their industrial strategy is smart transportation, smart cities. So that anything where any other country or organization is involved in that sort of business, that they're trying to steal that data. It is quite big business for them. So the FBI reckon that the US in 1 year lost staggering amounts of money, 225 to 600 billion worth of revenue because of Chinese activities through cybercrime. So move on. So this is why we do it. This is why we care about it. And these are the things that we face and are worried about as an organization. So it's ransomware by a nation state or cybercrime. And then we also are very concerned about the theft of intellectual property, particularly by a nation state, and the insider threat. So it's people that within OS accidentally or deliberately losing data. So they're the three main things that we focus on. So if we move on. So this is just a bill about what is information security. So it covers all of these things. It isn't just about the threats we've just seen. It's about phishing, it's about malware, ransomware, cyber, cloud security, security culture, risk management, application security, data encryption, data security, patching. It covers all of these things. It isn't just about cyber. And for us as well, it also means there's one final build on this slide, I think. Yep, it means ISO 27001. So that's one of the standards that we're looking towards achieving this year. One of the many that come into play at Ordnance Survey. So that gives you a feeling for what information security is about, why we do it, and what we need to do to make it work. And within Ordnance Survey, we have a team structure which helps us achieve this. We have a cyber operations team who basically are the security, the coalface. They do all of the monitoring of the traffic coming in, looking at the incidents, looking at the threats, and responding to them, and making sure we don't have any vulnerabilities in our world. And there are sort of 3 typical roles we have associated with that, which are basically security analysts, and there are some specialisms within the security analysis, where one example is a DLP analyst who looks particularly about the data loss, and there are other specialisms, but generally it's about security analyst type roles. So they're the ones that basically are at the forefront of what we do at the coalface. And then the next team is about cyber consultancy. So we saw in the previous slides about with Ian's and with Mark's about how making sure that cybersecurity is embedded in the project world, and that's the job of our cyber team, and they're part of the cross-functional teams that Mark referred to as well. So they make sure that we have security architecture in place, we have embedded security best practices in DevOps, and provide security advice to projects. So they're the external face of security, really. And then we have a GRC team, which GRC stands for Governance, Risk and Compliance. So as the name suggests, they look after what we do from a risk point of view in security, and own all the policies and all the reporting. So it's actually really, really important to go along with the other 2 teams. And the typical roles you see there are compliance analyst, reporting analyst. And then finally, we have an IAM team, or identity and access management team. And really their purpose in life is to limit the ability, if someone gets into our world, to traverse our network, to move around our network. So the first thing a hacker does if they get in, so if they break into, so let's say, I can see Mark in front of me. So if they manage to break into Mark's machine, what the first thing they'll do is say, oh, he hasn't got very good permissions. I want something more interesting. So they'll try and find another role which has more interesting permissions. And if we can limit the permissions that people have and how much you can find on a different machine in terms of identities, then that limits how far people can spread. So really, the IAM team with doing things like privileged access management limit how far a threat actor can traverse our network. And the typical roles you see in that are IAM engineers, associate and otherwise. We do have other specialisms relating to the privileged access management. So that's very quickly what we do, and I'm just conscious that I've used up my time now. So, but if anyone's got any questions, we have a question sections now. So hand back to Joanna.
Thank you so much, Peter. That was really insightful, and to all the panelists as well for your presentations today. I have no doubt that we'll have a lot of people eager to join Ordnance Survey after today's session. So yeah, like you said, Peter, we'll jump right into the Q&A session. So the first one is for you, Ian. Could you tell us a little bit more about the future plans for Ordnance Survey's technology landscape?
So, I think in some ways it's kind of more of the same. I think in terms of what I talked about, the adoption of cloud, the adoption of things like machine learning and AI, those are really key technologies, I think, for us in terms of how they enable us to do new things that we would really not was not possible. But also, I think a lot of the sort of sensing technologies, so satellite and aerial and kind of mobile mapping, where people kind of do this Google Street View type stuff, all of those are kind of technological advances that are giving us the ability to capture more data and do more things with the data.
That sounds so exciting. We'll stick with you, Ian. What skills and experience are required for a role as an architect at Ordnance Survey? I'm sure we'll have a lot of people asking that same question.
So I mean, it's interesting. I think our take position on that's evolved over the years. I think we definitely look for people who have got a good technical background, because as an architect you need to be a good technical background. But my kind of take on it is that actually, once you've proven yourself in certain technologies, learning new technologies is a thing that you can do. What we really do focus on is people who have those kind of more, I guess, kind of personable, relatable kind of skills. People who can work with people, who can influence, who can manage stakeholders, who have a good way of engaging with a wide variety of people. Because an architect, a root for me is an individual who joins up, who brings people together and provides an overall kind of sort of take. So it's very much that balance of kind of sort of softer skills and technical skills is the match between those two that's really critical for us.
Amazing. That sounds great. I'll open the floor to anyone that wants to answer this question. We have a question pop in the Q&A. Do Ordnance Survey have specific security architects within the solution architect session, or is this area covered by the main solution architects?
Shall I start with that one, Ian?
You can start, yeah.
You jump in. So one of the primary focuses of the cyber consultancy team we have is to provide the subject matter expertise in terms of architecture, but to only provide it to the architecture team. So they're the subject matter experts of information security, and almost all of the architecture team, the solution architectures, have a really good understanding of security. So it's been ingrained into almost every single one of them. So do you want to follow up on that one, Ian?
Yeah, no, I kind of agree with that. I think again, it's part of the solution architect role in particular being a collaborative role, working with, they're not necessarily the expert. Peter's got those people in his team, but we have definitely on the security front made sure that everybody is much more improved in terms of their skills on security. So their role really is to kind of own it as a whole, but then to engage with Peter's team for the sort of deep technical specialism that's needed.
Amazing. Thank you so much. We'll move on to Mark now. We've got someone asking, how do you measure success of the projects?
In some cases, it's easy. So that we'll create a business case for what we do, and there'll often be like a real quantitative measure. You know, perhaps it's about delivering a new product that's going to deliver some revenue, or it could be about achieving some kind of operating efficiency. So there'll usually be something that we can measure at the end of the project to do that. So often it could be a monetary thing. However, a lot of what we do at Ordnance Survey is kind of invention, and it's kind of a bit of a long run up towards realizing the value. And in fact, I talked a bit earlier about our investment in the AI and machine learning space. And the reality is we've been building capability in that space for many years now, but it's not something that we're exploiting significantly yet to generate things like revenue. So some of the stuff is measured really around our alignment to our strategy or our technical policy. So it's not kind of blind faith, but it does require a level of sort of judgment and discussion with the broader organization about where we want to invest and what our priority areas are. But yeah, we always look for things to measure. They say, you know, if it's worth doing, it's worth measuring. But sometimes they're a bit more qualitative, and they're about investing in platforms that we think will secure our future. But other than that, business cases.
Amazing. Thank you so much. We've got another question that just came through for Peter from Simon Bartlett. I feel like you know him. He's asked, I was desktop owner at Maersk in 2017 when we were wiped out by NotPetya. One of the outcomes of that attack was that we found we didn't really know how to rebuild our organization. Are you confident that in the event that our IT world collapse, there is the ability to recover well?
So having lived through one of these things, you completely and utterly understand how painful it can be. And I've lived through these things previously as well. Hardly surprising being a CISO. So there is a question about how much an organization wants to spend to resolve this potential issue, and how much risk they're willing to absorb. So we do have a pretty good idea. We've got good plans in place. We've tested them, but do we want to actually have a completely redundant infrastructure lying around waiting? Probably not. But we are reasonably well prepared, I think. So.
Amazing. And we'll stay with you, Peter. How can businesses and individuals protect themselves from information security threats? I'm sure you can touch upon this, but yeah.
So for individuals, and it's actually one of the key things is the point I made about having an IAM team. It's the same thing again, but it's about protecting your identities, and particularly passwords. So if you use any website, don't share passwords. Use reasonably complicated passwords. And so if you share passwords, if one website gets compromised with that password, you're automatically allowing all the others to be compromised you shared that password with. So don't share passwords, and use a password manager to manage your passwords so you don't have to remember them, because I can't remember 50 or 100 passwords. But if you use a password manager, it can remember them all for you, and it's encrypted, it's secure. Well, most of them are anyway. So, but that's definitely my advice, is to use a password manager to manage your passwords to protect your own identities. And that's what we do at a much bigger scale within an organization as well.
Amazing. I'm the same. I have so many passwords and I can't remember.
Use a password manager. They're even the free ones as well, but be careful, they're reputable.
I'll keep an eye for it. So this one is for Ian. How can organizations make the most of their data?
It's a good question. So we are, and as I said earlier, we are a data organization. That is our bread and butter. That's actually what kind of sustains us as a business. We kind of produce data, we sell data. So I think for us, managing that data well, focusing on things like the governance of the data, the quality of the data, and making sure that you've got kind of clear kind of ownership and responsibility around that data are really kind of key things that we put a lot of emphasis on. And so I think it's those disciplines around not just the technology part of it, but the kind of process and management of the data and the kind of governance of it that's really important. You can do a great lot with tech, but you can create a whole mess of data with tech. So actually making sure that you've got those kind of processes and governance in place is really important.
Amazing, thank you. And again, I'll open the floor for anyone who wants to answer this. I'm not sure. Yeah, do you have an in-house UAV technology and development capability, or rely on external parties to provide it? If you're able to answer.
I'll pick that one up. I think we use off-the-shelf kind of market kind of UAV kind of capabilities. So we don't develop the tech ourselves, but the application of that technology to our own kind of business needs, that's very much something that we do and that we manage. And from an architectural point of view, we've got oversight of that. A lot of kind of, well, some of Mark's teams are very much focused on how we take that UAV data and how we process it. So we don't develop the tech from scratch, but we do apply it to the OS context.
Amazing. And we just had another one coming. Does OS Ordnance Survey have any face-to-face recruitment events? Maybe.
But for Ben, maybe? I don't know, is it Ben, are you around?
Ben is it?
Well, I mean, I'll have a go, and so we do face-to-face recruitment often. We use Teams quite a lot for like initial interviews, and then where appropriate, we do like to meet people face-to-face. We have from time to time done events at Ordnance Survey's head office, headquarters in Southampton, but not that often.
Amazing.
Thanks, Mark.
We've got a lot of questions coming up. If we don't get to all of them, we'll obviously answer them post webinar via email. We've got another one for Ian. What are the benefits of a data-centric approach?
So again, I kind of sort of relate back to the kind of previous answer. We are a data business. That's kind of what we're about. So I think the benefits of being a data kind of centric business, that we very much we trust the data. We need to make sure that the data is of high quality, but we use that data for decision making, and our customers in particular will use that data to underpin their decision making. And so that's why it's really important for us to make sure that the data we're producing is to the highest kind of quality standards possible, because our customers are very much making decisions based on the data that we kind of provide to them and their own data.
Amazing. Then we've got another one for Peter. How can organizations ensure the security of their data in the cloud?
So there's lots of ways to answer this. Probably the best answer is it's actually not very different to securing it on-prem. A lot of the policies, processes, procedures are exactly the same. Some of the tools are different, and some of the default, so not the default, so some of security is done for you in the cloud. So if you're using SaaS solutions, for example, a lot of the security is done for you. If you're using PaaS, some of it's done for you. If you're doing IaaS, a little bit's done for you. So that's good. But the tools you have to use to achieve the same results as an on-prem are different. But the actual overall aims are exactly the same.
Amazing, thank you. Again, one for anyone who wants to pick this question. Presumably Ordnance Survey have IT, particularly security, cyber operations in-house, or are these provided externally or by third-party companies?
So I'll go for that one from a cyber point of view. All that we do is currently in-house. So
it's amazing, thank you. We've got another one. Are most Ordnance Survey staff office-based in Southampton, or do many work from home hybrid?
I'll go for that one as well. So it'll depend on the role, really. So ideally that they're Southampton-based, but we do have quite a few home workers. As you can see, I've dialed into this meeting from Kent in Tunbridge Wells, so Tunbridge Wells in Kent. So, but where there's a need, we'll have people that are remote and home-based, but there's a preference to have people that are Southampton-based.
Amazing. We've got another question from Simon Bartlett. Ordnance Survey creates and sells data. How is the company approaching the issue of sustainability and environmental impact, especially given the reliance on data centers?
Mark, were you going to answer that? Well, I'm happy to answer that.
Yeah, you go for that. I'll answer the other one if you like.
Okay. Yeah. So I mean, sustainability and environment is an increasing concern for us as a business, and we have a specific focus on that. It's something we monitor actively. Yeah, the use of data centers is something that kind of potentially kind of flies in the face of that, but it is something that we have a strong focus on. Our building, our headquarters, is actually a very sustainable and very environmentally kind of friendly building. And we actually have kind of engineers and stuff coming around and looking at it. We kind of give tours of it because it actually is quite a kind of leader in that sense. So it is an important consideration, and something that we do take into account with everything we do, actually.
It's probably worth considering. Some of our future product ideas are also around helping other organizations be more sustainable and help them manage their environmental impact as well.
Thank you so much. And again, I think this one will be more for Ben. Are apprenticeships or internships available at the moment? Or some?
Hello, yeah, sorry, I'm here. Sorry, yeah. So at the moment, we don't have any internships or apprenticeships available, but it's something that potentially is in the pipeline.
Amazing.
And I think just to add to that, one thing we do have a kind of policy of, to a certain extent, is kind of sort of bringing people in at kind of earlier stages and recruiting for potential rather than necessarily for experience. And that's kind of, we've kind of got a lot from that over recent years. So that is very much a kind of sort of approach that we have. We sometimes still need to bring in experienced people, but we look to kind of develop people ourselves.
Yeah, particularly in the machine learning space, we've got around, I think, 10 to 12 trainees that we've brought in, along with some experienced machine learning engineers that are helping, making sure that we're building and developing correctly in that space for the solutions that we have. So that's an example of where nurturing that young talent has been really valuable for us.
And it may be worth mentioning as well that we do have a graduate scheme annually as well that people can apply for.
Perfect. And I guess we'll just finish with this. It's not a question, it's a comment. Ordnance Survey does appear a very interesting place to work, particularly as I'm a cyber infosec professional and used to be involved in GIS years ago. So amazing. So that's all the time we've got today. But before you leave, the team at Ordnance Survey are actively hiring right now. And as a follow-up, we'll provide the link for their career page where you can find a list of their open positions, as well as the benefits, culture, everything. So if you are interested in career opportunities at Ordnance Survey, please register via the form in the email that you'll be sent, and we'll come back to you. Again, I want to thank to all the panelists and to you, Ben, for being here today. It was an amazing and insightful session, and hope you have an amazing and first day. Thanks so much, all.
Cool.
Yeah.
Thank you.
Thank you.